Hi, I'm Professor Lou, and I'm a physicist. The scientific method starts with a question. A real question that matters to you, one that you really want to know the answer to. For example, how tall is a particular skyscraper? If that skyscraper is too tall for you to get a ruler out and measure it, what are you going to do? You can go to the janitor and ask them, how tall is your skyscraper? But barring that, you're going to have to figure out some method of making the measurement indirectly. With your question in mind, how tall is that skyscraper? You set about doing some background research. You're trying to find ideas for measuring the height of the building without taking out a ruler. So you look, for example, at how the sunlight travels across the building. Is there something you can use there? No, it doesn't look good. You try to see whether you can use a protractor and a calculator. Finally, it occurs to you that maybe if I drop something off the top of the building and time how long it takes that object to fall to the ground, there might be a relationship between the fall time and the height of the fall. That's then a hypothesis. An idea. You're looking at the world and you're saying, boy, I'll bet there's a relationship between fall time and fall height.
Hypothesis. An idea based on observations prior to your experiment, and it must be testable.
With that hypothesis in mind, you set about trying to prove it or disprove it. Is there a relationship between the fall time and the fall height or not? Let's go see. You find some buildings that are relatively short so that you can measure their height with a ruler, and you drop things off those buildings, and you time the falls. Try a short building, measure the fall. Try a slightly taller building, measure the fall. It's taller still, measure the fall. And then you look for the relationship between the time it took for the fall and how tall the building was. And lo and behold, you discover there is a relationship. It turns out that the distance the object fell is proportional to the square of the fall time. Wow, that's a very useful observation. And with your experience dropping the object off short buildings, you can now go to the tall building, drop an object off it, time the fall, and figure out how tall that building is.
Experiment. When conducting an experiment, you can make observations with your senses and with the help of instruments.
The variable that you can control is the heights of the building, the independent variable. The thing you can't control, that you're measuring, you're observing, is the fall time. And technically that's called the dependent variable. To be meaningful and useful, an experiment has to be reproducible. If every time you do the experiment you get a different random result, it's not much of an experiment at all. You certainly can't use the results.
Collecting data. Use a bound journal to record your observations in an organized, clear manner.
A good scientist will be paying attention to all the other things that might or might not be controllable as you're doing the measurement. For example, what's the temperature today? What's the humidity? Is the wind blowing? Once you've collected your data, they're not science yet. The science comes from analyzing those data and developing models that fit the data and that can be useful for explaining our world. Once you've analyzed your measurements and found out whether you have proven or disproven your hypothesis, it's time to report your results.
So, what have we learned? The scientific method includes the following steps. Ask a question.
The scientific method starts with a question. What are you trying to solve about the world around you?
Conduct background research.
To answer your question, you begin by doing background research. You look at ways in which you might possibly answer that question.
Develop a hypothesis.
Once your background research has shown you a promising path, you develop a hypothesis, an educated guess about the relationship between independent variables and dependent variables.
Design an experiment.
To prove or disprove your hypothesis, you design an experiment in which you adjust the independent variables and measure the dependent variables.
Analyze the data to develop a conclusion.
Once you've made your measurements, it's time to analyze them. You look for relationships then between the independent variables that you can control and the dependent ones that you observe.
Communicate the findings.
Once you've analyzed your measurements and seen whether they fit or don't fit the hypothesis, it's time to report your results. Doing science is like solving puzzles. It's like detective work, where there are answers out there to be found, but you have to hunt for them. So it can be a lot of fun.
There is no single approach to doing science. Scientists vary their approach depending upon the question that they are trying to answer.